get started? All right. I'm using a microphone. He's using a microphone because of we're streaming and recording this. It's not so you can hear me better, right? I'm pretty loud as it is. I'm Dr. Sam, if you don't know me. Welcome to the Cybersecurity Seminar Series, right? So today we are very excited to welcome our next guest in the series. But first, I want to just mention a couple of things. If you're here for CSSE 145, please stick around after the talk. We've got a little bit more to do. If you're not, cool. You can grab a snack on your way out if you'd like. And to those of us who are remote, thank you for joining us remotely. Or if you're watching this later, sorry you missed all the fun. Right? Yeah, that's too bad. Today, we are welcoming Nathan Jenniges. He's from BlackBerry. He's a senior vice president and general manager of BlackBerry's cybersecurity business. Something you might not know about him, despite the fact that he works for BlackBerry, is that he once visited 27 different countries in 1 year for work, which is pretty amazing. This is also his second career. He accidentally happened into cybersecurity, and he'll talk about that in a little bit. So please join me in welcoming Nathan. Thank you.
Thank you very much, and thank you all for coming today. As Dr. Stam said here, just a little bit more background on me. I did have a tale of two careers. Oh, first of all, this is an AI presentation, so there is a lot of AI-generated artwork in here. I am a big proponent of it inside of BlackBerry. There's a whole thing that's been going on for probably the last year and a half. I'll be in a meetings and I'll go, AI can, and the people are like, Nate, stop talking about it. So I've used AI a lot. As I was putting together this slide, I've had a tale of two careers. After graduating from Rose-Hulman, I went to work at Motorola. I worked in mobile phones for the first half of my career. And it just happened to be that McAfee had acquired a mobile security company. A previous leader of mine went there to work and asked me to come over. 2012, I knew absolutely nothing about cybersecurity. I mean, nothing. I'd never paid attention to it in my life. I didn't know what a virus was in the cybersecurity world. And fortunately, a lot of time spent in education and learning was able to figure it out, right? To learn all of the details of cybersecurity. I spent a lot of time in my first few years there learning every product that we were doing in cybersecurity. So I understood what was going on in network security, what was going on in Windows security, what was going on in cloud security to be able to do this. And interestingly, as I was putting this slide together, I don't know how I also happened to work for two companies with circular logos and then moved to two companies with horizontal logos. But I joined BlackBerry a couple years ago. After a long time at McAfee, I had a person that came over to run the cybersecurity business at BlackBerry. He was starting as the president, and he gave me a call. He's like, Nate, I need a product person. I need someone that understands how to build products, right, and lead products inside of an organization. So today, that's what I do. He was recently promoted to CEO of the company, so I now work for the CEO of BlackBerry. I also learned a lot and have continued to learn even beyond Rose-Hulman, including 2 years ago, 2022, I went and did a 1-year program at Northwestern Kellogg and completed their Chief Product Officer program, which is a training that teaches you how to lead product organizations and lead engineers. Be able to craft the strategy and vision and motivate them and excite them and be able to deliver those great products. Now, BlackBerry, many people probably know BlackBerry. Yeah, you can find still plenty of phones on YouTube. It's the first thing, it's sad. You type in BlackBerry on YouTube and you still get a lot of phone ads from back in the days. But BlackBerry had a long history of innovation and transformation. The company was actually founded in 1984 as Research in Motion. It came out of research programs at the University of Waterloo in Canada and did a lot of stuff in network and telecoms back in the 80s, got into pagers and then the cell phones, and certainly there's now a movie even about the whole history of BlackBerry. But today, BlackBerry is in its, I'd call it the third chapter of BlackBerry. And we actually have two parts of the business. One of them that people don't know, Dr. Stam has it in his car, he said, is BlackBerry has a QNX secure operating, real-time operating system that is in over 220 million vehicles on the road today. It's the safety and security system that does all of the communications between the different parts of the automobiles in the electric vehicles, and that's a huge part. And we're building out a lot of other key components within that business. On the other half of the business, one in the blue box, is the part that I run. So I've got a portfolio of cybersecurity products that are focused on securing Windows, Macs, Linux, Android, iOS, servers, cloud things in Amazon and Azure. I've got products that help us secure mobile devices. I've got products that help us do secure communications and encrypted video and audio and text messaging and everything. So it's a really strong portfolio of cybersecurity products that I lead today. But we're going to focus, this discussion is around what is ongoing around software supply chain. It's been the evolution of the attacks and how AI is allowing people to get into software supply chains to be able to have attacks that are happening at much faster speed. So I'll talk a little bit about what's going on in the overall market. I'll share some stories from the many customers I get to visit. And then we'll talk about how AI is actually helping us defend against these attacks. So within, when we say software supply chain, there's two different categories of software supply chain. There's one where the attackers are going after companies that are building software. They're targeting people like you that are writing software, and they're trying to get into your networks, get into the code bases, get into the repositories, so that they can place, whether it's a small little library, a small piece of code, something that gives them a path to get back into the company. And we're seeing an increasing amount of this as systems have gotten more complex, where they're going in and doing this. The biggest one that sort of opened the world to this was several years ago when SolarWinds, which is had this happen to them. And the attackers got in, they put some software in, they waited a year and a half after they did that. Waited for all of the customers to go through their upgrades, get the latest versions of that software in their environments, and then they attacked. And we're seeing increasing amount of it. Today we actually just released our latest threat research report, and we're now seeing 3.8 new, completely brand new threat attacks every single minute. It's up from 1 3 years ago. And a lot of it's because the attackers are also using AI tools. There's plenty of things now. The other category of software supply chain attacks is just your traditional social engineering, where they're now getting so sophisticated to recreate websites, places that people might go to download that free tool or that free library they might need to put in. And it's a complete fake version of it. They'll actually make it look like the actual installer that you would be used to, but in there's additional libraries, and then they do phishing campaigns to try to get you to go to those sites and download them. So as we go through this, that's sort of the two categories, and this is where we have seen just recently all of these AI tools that are out there, the easy access to all these tools. There's specific ones like WormGPT. It's actually on the dark web. Someone took a ChatGPT and created a customized version of it to build malware. So we're seeing a huge increase in these new unique attacks. There's things like Black Mamba, which is a ChatGPT powered keylogger. Right? It keeps track of all the keystrokes and starts using AI to learn the behaviors, and they can then use that information when they get inside of your network. They can use that information to pretend like they're in there. We've seen, I had one customer who the attacker actually got in was in their Teams chat with the security team, mimicking one of the employees for an entire day, and they had no idea. It's scary, right? And what they're doing is they're getting in and they're directing them somewhere else, right? Trying to slow them down inside the environment. So it's a lot of scary things are happening with this stuff. There's another one, this chatty cat that we've uncovered, that literally you take some malicious package and you go change this and write new code that does the same thing. And it'll write entirely new code that will be unique and not caught by security products, and still does the exact same thing. It's a whole world, and it's causing an acceleration of the attacks that we're seeing. I get the pleasure, right, as said, I travel all around the world, meeting with customers, but the customer segments that I serve the most, I have a ton of healthcare customers, a ton of manufacturing customers, energy, utilities, governments, down to local governments. Your local governments, I'm sure the Terre Haute local cybersecurity is not the greatest, honestly, given my experience with many of these. So I get to hear a lot of great stories from the road on how they're trying to secure these. And if you think about these types of customers, they're not technology companies. They have a different mission and purpose in life. And one of the stories I love to tell is, and it's a great thing for engineers as you're designing products, is one of my friends that's a CISO of a children's hospital. And if you think about a lot of the things that people do in cybersecurity, it's like, okay, how many threats, how many things did we block, how many did we investigate, how long did it take? Like, they have all these metrics that most people don't care about. And he's really changed it. He's been long tenured because his team follows the principles of the hospital itself. And they measure all the work they do in cybersecurity on how much time did they disrupt doctors, nurses, administrators, how much did they affect the quality of the care given to the patients, how much did they impact families inside the hospital. And it's really, his team loves working for it because it's the right mindset, right? Focus on what the outcome of the hospital is and not necessarily all of the technical details. And they're probably the most secure company I know because of that. Because they don't waste their time on a lot of frivolous things inside of the environment. So a lot, and you see on here, I got a bunch of details about the different threat actors and tools that are used as well. And the interesting thing is that each of these has a different set of people that target them. Different threat actors, they use different tools and techniques. They've gotten so sophisticated that they can just go after specific industries. So oftentimes when you see the things in the news, right, they come in waves because they're able to go, hey, I got access to this type of software. I know this software is used in healthcare. I can just blitz like entire sets of hospitals at one time. And it's part of the reason why I love being in cybersecurity too, is we're doing something very important. If a hospital keeps running, like, that really makes a difference. So, one of the ones a few years ago, Romcom is one of the threat actors. And they've done they got a library, they got like an app store of spoofed apps. They've spoofed things like after the SolarWinds thing, people were measuring the network performance to see if there was oddities happening in the SolarWinds software. They made their own version of it with malware in it, so people got double infected, right? They would like have the SolarWinds breach and then install something. They've made versions of PDF readers. A lot of these are free tools, so you should always be skeptical if you're downloading some free tool, if there's something else packaged. And they do the same thing, right? They scrape the website, they make a slight variations of it. Now with AI, it's all automated. This whole step of attack preparation, these are now like one-click packages. You get them on the dark web, boom, you click and you pick your target and it builds everything. It builds the website, it builds the fake applications, it builds the installers, it crafts the phishing emails for you, and you just hit run. This same one was recently resurfaced late last year. It did attack a bunch of healthcare organizations in the United States that were helping to send medical supplies to the Ukraine. They had actually done enough, we were in the data class earlier today, for those that were in there. They had done enough data gathering. They actually knew exactly which hospitals were doing that, which ones were sending who inside the hospitals to target with phishing emails. And they did a variation of a remote desktop app. So a lot of hospitals, to access applications in the hospital for privacy of data and patient data, they often use virtualized desktop software, right, to access it, to make sure data doesn't stay at the actual endpoint. So they targeted hospitals that were using this application and got them to do fake updates of the application and then got their malware in. And all of these ones are designed to get you access, right? Once they get access, then they can do a whole lot of stuff, including joining the Teams chat and causing you to go down the wrong route. Another example was, those were the social engineering ones. This was another one. 3CX is a voice and video conferencing application. It's used in a lot of small businesses around the world. They've got 12 million users in 190 countries. This one, they actually had their network breached. The attackers got into their code. It was a North Korea attacker that got in, and they inserted into the installer, they created dependencies for libraries in the installer where they had their malicious code. And they got it into the system, and then as the developers were building the final package, all of their libraries got signed with the company's certificates. So it all appeared legitimate. It all looked like code that came from them. It was signed by them. It was part of their package. And then it went out in updates, and then they used that to go after the people in the healthcare industry. Now, these types of attacks, we literally find in many cases where these attackers are so patient. Some of these, this one we think they did it in the fall of 2022, and they waited a year. Right? They have the patience to wait. We know some are ones that take years to wait, and one of the challenges for companies, right, is you don't tend to keep all that data for that long. So if it's something that happened a year ago inside of your environment, you might not have data at the time the actual attack happens to even know when it started. And this is happening time and time again when attackers have this type of patience. Now, this is just a cool video, my threat research team. So I have a bunch of, as part of my team, I have got a whole set of threat researchers. They're in 14 countries around the world. Part of doing threat research is you do have to live in the different environments. You have to understand the attackers, what motivates them, why they're doing what they're doing, who they might be targeting because of that. A lot of the attacks have to do with stuff that's happening in these local environments. So I've got a bunch of threat researchers and PhD data scientists that work for me that do this stuff. They made this cool video, because videos are always cool, of an actual attack happening where the attacker is in and continuing to find what's going on. They get a one breach in, and then they start moving and hunting and finding and looking and building out the nodes. And on their side, the attackers actually have these tools that let them visualize your network, right? And they just keep hunting, 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 jumping around. The green one is the security person trying to find them. and they just keep jumping around, and you can't really ever figure out exactly where they are, what endpoint they're on. You can get in and off of the devices and not even be seen. This is what they do. And now with, it just keeps like, I mean, they can do it. The interesting thing is I spent some time actually with a company that was a bunch of PhDs out of a university doing data science, and they were like trying to get into cybersecurity, but everything they'd ever done was time-based. Yeah, it's easy if it's a machine that you're trying to predict if it's going to break down in a maintenance situation. But in cybersecurity, I kept telling them, like, time doesn't matter. You can do that exact same attack in a couple minutes, or you can let it take a couple years. So it's interesting, and I put in here sort of the why do we seem to be taken by surprise? Like, it seems like every day someone's taken by surprise in the cybersecurity space. And a lot of it is the software and systems inside of companies are truly complex. Not only just the number of software and that is used inside of companies, but imagine all the settings and configuration and optional modules of things. I just talked to a CISO that took over, he just left his company and went to a hospital. He calls me up the first day, he goes, "I tell you my first biggest problem, Nathan. I have 86 cybersecurity vendors in my network. 86. And I go, wow. And the average cybersecurity probably has like 200 settings. Like, you start doing the math on here and like just your cybersecurity products, what the complexity of configuring it. And then you're asked like, hey, if this attacker came after it, would I be protected? You're like, theoretically, yes. I can't say so because we don't actually know how everything's configured inside of the environment. So it's a daunting problem. And that's just the cybersecurity vendors, right? He had thousands of other applications and every variation of operating system you can think of in the environment. So all of the security and product and configurations and complexity causes, there is still a lot of companies out there too that are overly compliance first. They get checklists of things that they're told you need to do these things, and they just focus on checking all the boxes. We had one of my customers actually got breached, and we went in and we're doing the investigation. Their systems were down for a week, and we went in and were investigating with them what happened and what was going on, and we found that they had 100 devices where they'd installed the security software, but they didn't turn on any of the features. So it was just sitting there doing nothing, literally nothing, and we're like, well, I can tell you where the problem is. I can't solve your problems if you don't use the products. Again, we don't also understand the adversaries enough, especially inside of companies. And I think there's things that are coming that will help us there. But the last one is we still have too much trust of software inside of companies. Most of the software that companies use, they market it as like, this is trusted software, don't worry about it. Just let it run, I don't care what happens. And this is when your software has been compromised, and then you've trusted it, and you say, I don't care what it does, it's trusted software. Of course you're going to be breached, right? And the biggest thing is a lot of times you didn't even collect data on how that software was running. So you had no idea that it started acting different than normal. And you can't expect in this world that every software vendor out there is going to actually also understand how to do security. So what do we do about it? When you have a problem that is basically infinitely complex. I tried to do the math once and I couldn't find anything that could actually calculate the number when you start taking like this many security products, this many configurations, all these OSs and combinations of software that could be on every device. The number is, it's probably approaching infinity at this point. You've got to have something that doesn't rely on humans. Today, too much of it is still, most companies have, literally, I've been in some of the security operations centers. The ones you see on TV, they actually exist. I went to one in Michigan that runs the security for a lot of hospitals. And they literally have a command center. It was screens all around, people sitting at the desks. It is still heavily humans just looking at screens of alerts going like, oh, that just happened. Is that bad or good? I don't know. Let me take some time to investigate and hunt it down. Most of the products still, they'll end up finding out that no, it was actually something good. I had a customer years ago, a very large retailer that starts with a W. I'm not going to try to do bullseye like you did. But they have over 10,000 scripts internally that are unsigned. And over the years, they did stuff like, well, we've got some data being collected here. We need it to go back to this file server, so we, run a script that grabs some data and laterally connects to this back office server and transfers the data over, right? It's like, well, that kind of is suspicious, right? That could be an attacker in there moving data. So a lot of crazy things happen out there in the world. So I believe AI has to be the piece to solve this. The attackers are already using it. And when you have this type of complexity problem, we're already seeing a lot of applications that I'll go through. There's really two classes of AI that we're using. The first one that really has been around for a bit in the cybersecurity world is what I'd call on the predictive side. Given some inputs, can I predict whether this is something bad or not? And I'll talk through some of the things that we do there. And then more recently now, obviously the unlocking of generative AI tools. And where we see these being the most powerful is helping explain things. And I'll show you how we're using some of these tools in our products today. One of the pieces we started thinking about as we were jumping in here, starting thinking about all of the different ways, right? We did brainstorming sessions on how could we use generative AI, where could we use it, where would it be useful. There was a person at Google, Barack, I forgot the guy's last name, Turovsky, who's now at Cisco, but he made a framework of just broad market, how you could use generative AI, and he ranked everything on a scale of how fluent does it need to be, and how accurate does it need to be. And so we brainstormed around all of the cybersecurity things and came up with, there's a set of things that they're more informal, they're easier things that you might need to be able to do. How do I take this and send it as an email and communicate something? There's more ones where we're at right now is in the yellow category, where we're thinking through how can it explain a whole set of complex security data that you have collected in simple ways that different people can understand, and just answering questions. A lot of, you start thinking about companies, now these attacks can attack anyone. That 50-person company that's making some got a little manufacturing line, do you think they have anyone that knows cybersecurity? No. I had some remodeling done on my house, and the builder that did it, I asked him, I was in because I was looking at his computer. Anytime I go anywhere and someone leaves their computer unlocked, like my chiropractor's office, I start playing around with it and looking around because I have to give them some guidance sometimes. But it ended up being that the entire network, all of the computers and everything that they were doing for security was done by his 14-year-old son. Right? And I was handing him my data too. I was giving all kinds of information about my house and my family and everything. So it was kind of scary. So things that we can do to help people. As we go further forward, we see opportunities to help people in that other area. When I said you got all these, like there's 200 settings, I don't know what's needed, right? Why do I have to care? Shouldn't AI be able to help me understand the different users and devices in my environment, what the potential threats are, and just recommend, like, here's what you should do. So we're doing a lot of research into these areas in the red right now. But we're probably in the, I'd call it the early majority of companies that have gone fully into using AI tools. We're using it in our software development teams. I already have people that are using it to generate code, to build automation and testing. We're starting to even use it for product security, where it can analyze code, right, and try to take all kinds of different attacks on the code. We're actually using it to automate and fix the code, to close down some of the vulnerabilities and holes that we're finding in our own software. Eventually maybe we'll figure out how to help others with their software as well. But we're also using it inside of our products. The core one that we've done is just around understanding if you got a Windows laptop and something's trying to run or you're trying to open a file. We've got extremely powerful machine learning AI that can detect those threats. We're also using it in the product to explain security events to people. And I'll show a cool demo of what we're doing on that. And then the next space that we're doing is we've got some tools we built. We have a whole team that whenever a customer calls us and they go, we think something's going wrong, we got a team that immediately gets on the phone call, gets access to systems, and starts trying to understand. So we're starting to use some tools there as well. The key one that we do, this is, so I got BlackBerry. Cylance was a company that we acquired. It was a startup that first launched. They were the one that launched the first machine learning based product now 10 years ago. So we are now 10 years into building machine learning models around Windows and Mac and Linux devices and all the different types of files on them. We take in 1,000 plus vectors from different process executables, from PDFs and Office docs, and we look at the network events from the devices, and we've trained and classified it. We can immediately, as soon as something tries to launch, we have never seen it before, and we can classify it. We can tell if it's legitimate, if it's ransomware, if it's good software, if it's Trojan. We're able to immediately classify it and understand what it is, because we've built up such a treasure trove of data, and then we'll use that to stop the attacks, right? Block that thing from launching. We can get it off the endpoint. So a huge amount of time goes into this, and it is a order of magnitude scale. You will see here that we see 24 million unique things hit our AI cloud every day. And we block, it's a staggering amount of things that we're blocking every single day for customers. The other piece that it's always interesting that we hype a lot is that the models that we've designed over the years also last a while. You can see some of the models from back in 2016, 2018 are actually still effective today, because not a lot has changed in how an Office doc works, or how a PDF works, or how a Windows process launches and operates. And so that's sustainable. And what's helped us with healthcare and manufacturing and industrials is there is a staggering amount of Windows XP and Windows NT devices out there in the world today. And we have our machine learning goes all the way back to those old operating systems. And I'm not joking. There's probably 5 to 6 million Windows XP machines still in use inside of companies today. And you talk to, like, there's still a vast amount of ATM machines in the world that are Windows NT. Or down in Latin America, you can visit a McDonald's and the credit card reader is Windows XP. he's dying over there, but if you, I've actually asked a customer once, I'm like, why do you still have this? And he's like, look, if we're manufacturing something and we make 50 cents on every widget, and it's going to cost me to upgrade all of this stuff, right? All of the hardware, the software, I got to rewrite all the applications to program things. We're not going to be profitable for the next 5 years, so we're going to do this until it stops working. I know as part of my career actually is McAfee, when I was there, we got bought by Intel. So I spent 2 years at Intel. We got merged in. It's a funny story too, because we got merged in and then they rebranded us from McAfee to the Intel Security Group, and they gave us these nice jackets that said Intel Security. And I live in Portland, Oregon, where Intel has 25,000 employees and massive, fab sites, and people thought I was a security guard for Intel. But I'm glad that didn't last. But similarly, when they set up a new chip fabrication site, the exact same equipment is running 20 years later. Nothing changes. So the ability to build these types of models and have them have longevity also, I think is important. As you get out into the world and look at all the different things that are built, things do last a long time. The other interesting thing we've done is, the original stuff we built was things here like this PDF doc model. And you look at all the different things a PDF can possibly do and how people could put stuff in. You're able to easily classify sort of the benign behaviors, like these are the things in blue, and the malicious behaviors. So we've got a pretty good model that, if there's someone's injected some type of script into the PDF, we can instantly know that that's a bizarre behavior. What we've done more recently now is we've actually merged that in a fusion transformer thing with a generative AI tool that also processes all the text and is able to decipher fairly accurately whether we think it was actually a phishing PDF, where it was a generated document by an attacker that was trying to phish as well. And that adds extra value to a security person, right? If there's a PDF that didn't open and it was just said, BlackBerry said it was bad. Why? Well, what about it was bad? Our ability to now differentiate a little bit more, leveraging these tools, gives us a much more sophisticated model, is able to give a lot more details for the security teams. Another one. You'll go into a lot of security products and you'll see lots of detailed information. This is easy to explain, right? Anyone want to try to summarize what's going on here? Most people cannot process all of this types of informations and files and hashes and IPs and processes and all of the things that a cyber attacker is doing. So one of the pieces that we introduced last year is, you will see as we go in, this is an example in our product. Again, a whole bunch of data that the average person doesn't know. But what we've done is, you'll see here momentarily, dmw.exe. What is it? So we've built in and trained our own large language model, not general. You try to use ChatGPT for some of this stuff, it won't work. It's too generic. I had a customer actually send me a thing. He has a data lake and he was trying to understand if there were phishing attacks trying to breach it. And he put that in a ChatGPT and it literally thought he wanted to phish at data lake. It kept changing and he's just like, so we've built in some really cool things here. Like this one will explain the MITRE tactic to you. And one of the things that we found as we researched this, I had my user experience research team do a lot of case studies with security teams at our customers. And we found that a lot of these chat GPT type tools, you have to know what to ask. So we've pre-built in the questions based on where they are in our product, what they were trying to do, and actually who's logged in. So in our case, we've got roles assigned. So we know if it's a security analyst or if it's the director of IT. And we're able to change the answer to match whatever that role of that person is, so they get the right information. And as soon as I saw, I started pushing my team almost a year ago on this, because I was watching customers. I love to go watch them use the products, and I was watching them copying and pasting stuff from our product, opening up another tab in the browser and going to ChatGPT and trying to search. And I was like, wait, I don't want you leaving my product. I want you to stay in here. I want you to be able to get your job done. So we're finding all of these cool ways to do this. It'll also translate on the fly into whatever language the person set. So I don't even have to bother with that anymore. And customers are just loving it. It's enabling them to get their job done a lot faster. They can quickly then, the next one I'm working on is to, a lot of security people when they're using the products, like, can you summarize my day? What did I do, right? Hey, we've kept track of everything. We know exactly what you've done inside of this product. So, wrapping this back up around the capabilities, what can we do with AI for product security? As we think of, if you're going to some company in the future and you're building software, we really do need to leverage a lot of the AI tools. We're looking at how we can build something to actually provide to customers as well as they're building software. A lot of places, no one actually tests like the entire system. They don't think through all of the components, how things are interconnected. So much of our software has like APIs and it's connected, like ours, we got like 100 of them that we connect to. But no one actually tests those, and oftentimes those are the source of breach. We don't really analyze all the dependencies that are built into the products. And we don't baseline and understand normal. I think of things like SolarWinds. If they'd had something that said, if they'd handed a report to the customer and said, like, this is how the software should work. It shouldn't do these other things ever. Then it would have gotten flagged immediately. Now, fortunately, we're one of the few that actually does, in our modeling that we do, we actually model good also. So we don't care what it is. I don't want to know. Anytime anything's launching, we don't even look at what it is. We just say, we're going to watch what the behaviors are. But not a lot of the cybersecurity world is still doing that. So we're looking at, how do you really use these tools to baseline and understand what your software should do, so that you can maybe self-identify when it's doing something anomalous. So with that, I will open it up to any questions you may have.
Let's thank Nick for his talk.
Thank you.
If you've got any questions, please let me know. I'm going to try and use the mic here so we can capture it for the streamers. Any questions? This is the part where I get to run around the room.
First one in the back for him. He needed to run up there.
Sorry, so how do you ensure that the answers that the AI gives for like the explaining an attack, how do you ensure those are accurate or not like misinformation or just random things that the AI is making up?
Yeah, how do we make sure that the AI is accurate? Because that is a problem. So part of it is we have built our own large language model based off of AWS Bedrock components. We're based off of the Anthropic models, just from a language perspective. But we have purposely trained it only on our own threat research. So all of the research and publications we've done, we've trained it on all of the user manuals and help articles and things of our product. I've had it also take all of our requirements that we build into Jira and user stories and epics that how our product actually works. It's trained on that as well. So we have people that monitor it also just to make sure that it's properly functioning, but it's very specifically trained just on our stuff, so it doesn't answer wrong. We tried to use some, like the private version of ChatGPT, the enterprise license version. It does that, has that problem, and you can't stop it. It's not like you can retrain it and say, forget this stuff. It still knows it. I guess I got it.
Yeah, so I'm just curious. You say you use machine learning to detect and prevent attacks, any sort of attacks. What's the rate of like false positives that you would get with these machine learning algorithms?
Yeah, so what's the rate of false positives on them? When the company first started, they focused on just the bad, right? And just modeling the bad, and the falsing was tremendous. I'd say over the last 3 or 4 years, we've put a lot more focus into building the models around the good, and our falsing has dropped off a cliff. We actually have our engines actually, and you can go to Google's Virus Total website where it actually shows you all of the different security products and their engines, and they run samples against them every day. We've been falling off the list because we hit 0 false positives too often. But it took a lot of very specific work. For anyone that might be in the data science realm, you've got to have lots of software and different applications and a lot of research into how all of these different applications work, especially in the corporate world, where you will go into a lot of companies and find the thousands of custom applications that they've built internally. And you can't predict those behaviors at all.
In like an AI attacker versus an AI defender kind of battle, is it about which of those tools is the fastest, or which knows each other, like knows what the other wants better for like a cyber attack?
An AI versus AI, who wins? I don't think we haven't seen like pure AI type attacks where it's just some autonomous thing that no one's actually behind and it's just running the attacks. There's typically still somebody behind the screen on the other end, right? There's a lot of AI stuff that helps them simplify building the tools. It makes it a lot faster for them once they get in to the network. I think we're still, the attackers right now are ahead. That's the reality, right? We're seeing this ramp up because they've been using these tools for a lot longer. And we're starting to catch up. That's what it's kind of the history of cybersecurity too. If you go and look, it's like attacks, new technology, attacks, new technology, attacks, new technology. And we're in that next wave here. And I believe that as we introduce more and more of these capabilities, it's going to let us catch back up a little bit. But you're right, in the long run, speed will become an issue. We just haven't seen that yet today.
In the nature of the world with cyber attacks evolving so rapidly, when you're rolling out new software to counter that, how do you decide when it's good enough?
How do we decide if the software is good enough? Interesting question. Hadn't thought about it that way before. I err on the side of get it out as fast as possible. Like that AI assistant, even if we knew it couldn't do everything we wanted, like we just started turning it on for customers. I've been changing the culture of the engineering team. I was telling this story earlier when I joined 2 years ago. I got 600 engineers, and one of the first things I was told is, oh, well, we don't talk to customers. We already know what they need. And over 2 years, I've completely flipped that. We have, even our engineers get on calls with customers, and we've trained them on how to ask the right questions, right, to really understand what they're doing. And I've added in the concept of, like, as soon as it's good enough, turn it on. As long as it doesn't break something that they're doing every day already, if it's like augmenting it, absolutely turn it on. In our case, we do daily tweaks on the ML model that's running in our cloud service. So all of the endpoints, if they're online, connect to it. But we've actually taken the exact same model that's in the cloud, and that's what runs on the actual Windows desktop as well. So if it goes offline, we still have machine learning when it's disconnected. But on the cloud, it's every day.
All right, I heard the bell ring, so let's thank Nate for joining us one more time.
All right, thank you. Appreciate it.
And thank you all for joining us. Please take some snacks on your way out. And if you're in CSSE 145, stick around. See you next time. We have another one next week, by the way. Come back, same time, same place, new speaker.